Hello and welcome to my office. Today we're going to go through part 2 of doing functions in C++ and looking particularly at the difference between pass-by value and pass-by reference. So in this first exercise we are going to take a function, write a function called 2times that takes an integer parameter value, doubles that integer, and then prints it out. And in our main function, we're going to call it and then print the integer again within the main function to see what's actually changed, if anything. So let's go get started with that. We want to make our function called 2times. So I'm going to declare it here, and it returns nothing. So type of this is going to be void because there's nothing that's actually returned. And it's called 2times with a number. So I'm going to be calling it later with a number, and we're going to define it as int 2times. You can call the parameter here something different than num if you like, but I'm actually going to leave it as num, and the reason I'm going to do this is so you can see a little bit of the difference between what happens when you have two variables declared with the same name in different parts of your program. So I have int num here, and I have int num here, and we're going to see shortly what the difference is between these, even though they have the same name. Okay, so in here I'm going to take my number and I'm going to double it. So number times equals 2. Also you can do number equals number times 2. These do the same thing. And then we're going to print it out. Yes, take it, double it, print it out. Okay, cool. So cout 2times my number. I guess I'll just write it in here. Gives me my number. There we go. And now I am just taking any integer, so we're actually just going to initialize this to something. Let's say 5. 2 times 5 is 10. So this should, let's say, 2 times, parentheses or not, gives me 10. Let's double check. Okay, what am I mistaken? No return statement in function returning non-void. Yes, because I said that 2 times was a void and I wrote int anyway. So let's do that. Looks like actually, interestingly enough, the online C++ compiler actually ran the code anyway and gave me the right answer, but I do still note the warning, and if you can avoid warnings, it's generally better to do so. I believe if I were to compile this in Linux, I would similarly get the same warning, but the compiler would still go ahead and I could execute the code already. But this warning is here to sort of indicate that although you can have your code promise that the function is going to return a different type than it actually does, it's usually very bad practice. You want to make sure that whatever your function is defined to be returning to you is actually what's it's returning. And in this case, since we don't return anything, we're going to declare this to be a void. Okay, now this is all well and good. And now the other part of this exercise was to call, print the integer again within the main function. So I'm just going to print it one more time. The value of num is num. And now you'd really think that this is going to just print the same thing again. It's going to print another 10, right? Well, let's take a look. This is kind of strange. 2 times gives me 10. I took my number, multiplied it by 2, and I got 10. But down here, which happens after the 2 times function is called, I call it in line 22 here, and I print out the value of num in line 23. But the value of num I print out in line 23 is 5. So what exactly is going on here? And this leads us to the second exercise, which is take this program and put it into pythontutor.com/cpp.html. And this is a website that allows you to visualize what's going on in your C++ code. So we're just going to take everything here and put it into Python Tutor, and we're going to go step by step and actually see what is happening one step at a time in this program. I find this a really good website for making sure you can kind of visualize in your mind not only what's happening at each step of the program, but what data is being tracked at any given moment. So at the beginning of your program, before you run the line of code that says int num equals 5, your program doesn't really have anything going on just yet. This first line of code is going to be the one that actually sets apart sets a value for num. However, when you compile the program, you'll notice that already there's a box for num, and that's because when I compiled the C++ code, C++ realizes, oh, there's a point in your program where you're going to declare an integer variable. Notice it says integer here. And that integer variable is going to have some value. We don't know what the value is until you start running your code, but it's going to, your program is going to need to have an appropriate amount of memory on your computer to actually hold an integer value. So the first line of code is going to set that value, and it's going to be equal to 5, which is what we expect. And now here's where things get interesting, is where we call a function. So when we call the function, you'll notice over here there's a thing that says stack. This is what's called the call stack, and it refers to essentially every function of your program that's running at any given time. Now by default, we always start with the main function, but when we call another one, the call stack is going to add onto it another function that's going to be operating completely independently of main. So you'll see here in my next step, I'm now inside the 2x function. That also is going to have an integer, which is going to have some value called num. And anything that happens inside this function only affects things that's actually going on in the function. So for example, we'll see in a little bit exactly what I mean, but importantly, there's a different area of memory that's storing this integer compared to this integer up above. So the first thing that happens is because I passed num down here in line 14 and num was 5, the value of num over here is also equal to 5. And so my code continues onward. Now in line 7, this is where things change a little bit. This says to take my number and double it. But which one? There's a number here, there's a number here. They both have the same name. And the rule for this is whichever is the most recent function that has a definition for that name, that's the one that you actually affect. So when I double, only this number changes from 5 to 10. The other one does not. It stays here exactly as it is and isn't affected whatsoever. And the reason for this is 2x is what we call a pass-by value function. This means that when I call 2x and I give it the value of, say, this number, it makes a copy of that number inside of the computer memory. That copy is not the same as the original number. You can see there's two different numbers here that we're working with. So when I modify the copy, that doesn't modify the original value, the original variable. So I print out, 2x gives me, and in this case it gives me 10, because when I try to reference this num here, we're looking at the most recent one, which is this 10. So it prints out 10. But when this function is done, we go back to the main function. So it's all gone, we leave it, and now our original number is unaffected completely. So when we try in line 15 to print out its value, the value of 10 is gone completely. We don't know what happened to that or where it is or anything like that. It's just gone. We only have what our original number was, which is 5, and that's what gets printed out. That's what gets printed out in the last line of code right here. So anytime you're kind of unsure of what your C++ code is doing at any time, a really good approach to trying to figure it out is to do a sort of a step-by-step breakdown of what's actually happening in every line of code that you're executing. It can get very overwhelming to write down a ton of code and try to figure out, okay, what's this chunk of code doing here, this chunk of code doing here. Sometimes you really want to just get down to the one line at a time. This line does this line does this. And this code visualizer is actually very good for showing you the values that you're working with, the output that you're printing, and what lines of code you're executing at any given time. So highly recommended, although it does take some time to compile, so it's not something I recommend you're doing if you're making a lot of changes and doing a lot of coding really rapidly, because you do have to wait a bit for it to operate. And it doesn't work with very, very large code or code with multiple files. So some restrictions, but the visualization I think is really, really good. Something I would recommend. Okay. Now let's look at our second exercise. So in our second exercise, we're going to get an integer from the user, write a pass-by value function, like the one we just did, that takes the integer as a parameter, prints its address in memory, that's something we haven't done yet, squares the integer, and returns it, and then repeat this process with a pass-by reference function. So there's a lot of things that we're doing in here. So again, breaking it down one step at a time. Write a program that gets an integer from the user. We're going to do that first. So here's my code from before. I can leave the 2 times function here because I'm not going to need it again. I just don't want to call it anymore. I do need to get a value from the integer, an integer from the user. So please enter a number. Okay, so I've got a number from the user. It's called num. And now, what's the next thing I want to do? Write a pass-by value function that takes the integer as a parameter and is going to do some stuff. So we don't have a name for this function. It says it's going to return the squared integer. So that means it's going to return an integer type. And we can call it whatever we want. So I guess we're going to call it funny function. Who knows? Funny function. It takes a integer number as a parameter. Okay, so here's my funny function. What is the first thing it does? It prints the address of the integer. That's not too hard to do. So the address of num in funny function is, and to print the address, so if we printed the number, this is just printing the number, we want to print out where is the number in our computer, and it just like your house has a house number, all data in the computer has an address number that says here's where the data is. So you can just put a little ampersand in front of this and it will give you the address. Before we move on, let's make sure what we have works so far. Also, we're supposed to return the number, so let's do that. And we'll call our funny function with our number. So just to verify that it works, we'll give it a try. It's number 5. The address of my number in funny function is this wacky looking thing. What the heck is this? It's got even some letters in there. What's going on with that? So you've probably at this point heard of binary. This is like the kind of stereotypical computer language of zeros and ones. It's what most computers work on. You either have, if you have a switch, it's either on or off. If you have electrical current, it's either going or it's not going. And so computers operate mostly on zeros and ones. However, sometimes this gets really annoying to represent everything with zeros and ones because it takes a lot of zeros and ones to show something. So the kind of next step up from that is to not use decimal, like base 10, the mathematics that we're used to. We use base 10 because we have 10 fingers, 8 fingers plus 2 thumbs, I guess. And so it's very easy for humans to think of things in tens because naturally it comes to us that, I have that many things or this many things multiple times. Since computers are working in what we call base 2, binary is base 2, meaning the only numbers you have are 2 different numbers, 0 and 1. Turns out that the next easiest way to work with things is actually to increase from 2 to 8. And so in a computer, a 0, something that could be a 0 or a 1 is what we call a bit. You may have heard this term before. And 8 bits, 8 0/1 options, combined yields what's called a byte. And you've probably heard the term byte as well, kilobyte, megabyte, so on. And a kilobyte, as you might guess, is 1,000 bytes. And so you can probably imagine how many zeros and ones it takes at this point to represent anything on your computer. If you think that, for instance, a picture you take with your cell phone might be 3 megabytes, that's 3 million bytes. That's 3 times 8, so 24 million bits. 24 million zeros and ones to represent a picture. Now, bytes, again, can be, we can go kind of the next step up from that. So from 8, we go up to 16. And this is where we get into what's called hexadecimal. So hexa meaning 6, decimal meaning 10. 10 plus 6 is 16. Means that we now have a number system that works from 0 up to 15. And then 16 is is actually written as OX10, which represents 16. I can probably do a whole lecture on binary and hexadecimal and how these numbers actually work, but mostly getting to the point of what's relevant for this. Everything that appears after the OX here, this OX is just a symbol that means this is in hexadecimal format. All of this is the label for where my number is in the computer. So if I told the computer, hey, go to address 7FFC29D8434C, it goes there and finds this number 5, because that's what's there. I think in a little bit we'll find out exactly how many bytes it takes to represent one of these integers. But importantly, this is where the value is stored. The reason this is important is because when we were looking at Python Tutor, each one of these little boxes here, this thing here, are stored at different addresses. So sometimes it's helpful for us to be able to see, if we're not using one of these code visualizers, where are each of these variables actually coming from. Okay, we've printed our address. The other thing we were going to do was square the integer and return it. So we haven't squared it yet. To square it, not too complicated, we can do num equals num times num. That's a square. I believe we can also do num star star 2. This means num to the power of 2. Sorry, num equals num star star 2. So single asterisk means multiplication, 2 asterisk means exponent. Exponentiation, exponents. So this should give us num squared. And just to verify, we're going to print the value of it. Thanks, Ken. Probably should disable notifications. Okay. Let's print out the value of num. Where it is. No. Let's take a look. Sorry, what did I make a mistake of? Okay, it's possible that the double star might not be valid. There might be another way to do it. I don't think this will be accepted. This is the way that you might do it on your calculator, is using this little symbol. But I think this is probably going to be wrong too. So to square it, we'll stick with the original plan, but the double star I think might work in something like Java. C++, we might just have to do the classic number equals number times itself. Okay, 5. So 5 squared is 25, as we expect, and there's a value in memory where we store it. Okay, all well and good. Now, repeat this process with a pass-by-reference function. So that should be interesting. So we're going to do this again. But we're going to comment this one out, and we're going to do it a second time, but this time we're going to put an ampersand before the number, and then do everything exactly the same way. Now, to show kind of the difference between these two, I actually think maybe we'll go back a second. You know what? Yeah, let's go back a second. And we're going to print out this number here. So the address of num in main is the address of num. The value of num at the end of main is the value of num. This is really important so we can see the difference between running the function, what happens before and after running the function with the two different kinds we're going to write. So off the bat, let's try a simple, 5. Okay, so notably here, the address of our number in main is this thing. The address of our number in funny function is slightly different. You see it ends with OC instead of 24. And the value of our number at the end of main is 5. Just like before, we're not actually squaring this 5, we're squaring the other one, which is why we get 25 in our function. We only get 5 in our main. Now, what happens if we actually just add an ampersand? Let's try this again. Isn't this interesting? I didn't actually do much. I put a single symbol in here. But when I did, the address of my number in main is this thing. The address of the number in the funny function is the same thing. When I square my number up in funny function, it's 25, and the value of my number at the end of my function is also 25. So that's the first part of this exercise, but I'm actually just going to jump right into part 2 of it, which is to, again, copy all this into Python Tutor and show what's happening at each step. We're going to do that for each version of our function. And then we'll do this last part, which is to try to add const before the parameters in your functions and see what happens. So I guess there's only one parameter, but we'll try it out. Now I need all of this code into Python Tutor. We're going to start with the normal version without the ampersand. The compiler here is much slower than the ones that you might have on your computer. So, okay, when we go through our code, we have to enter a number. I guess this, since here's kind of a limitation, I suppose, of Python Tutor is it can't actually take your input. So instead of that, we're just going to skip this line. We're going to write in our 5 ourselves. I might modify these slides a little bit just to reflect the changes that I'm seeing right here and how I have to do things. So enter a number, it's 5. So here's our 5. The address of that is this, which is the address of this value right here. We go into our funny function. There's a 5. The address of it is a little different. See, it ends in, instead of DC, it ends in BC. And so this number is at a different place than this number. When we square, this is the number that gets changed, and it prints out that that's a 25. And when we go back to our main function, we print out just the normal 5, which is there. Now what happens if I add a single ampersand right here? Okay, there's our 5. The address of our number is here. Now look at this. This is really interesting. Notice there's no number here at all, actually. In Python Tutor, what we have here is something we're going to see in much later weeks in more detail, which is called a pointer. And so instead of actually having a copy of the number 5 over here, we just have the address of the number 5, and any time that we're going to modify our number, we're going to only modify this. The address of the number is going to print out being the same thing. It ends in DC there, which is the address of this. That's what we're printing out over here. And this time when we square things, we're actually going to follow this little arrow and say, oh look, here is my number, and that's what we're going to square. And that's why when I try to print out the result, I print it out, I get 25, I go back to my main function. Now I've modified the number in my function. It's now been changed to 25. And so when I print out the value again, now it's been modified for good. So the reason that this is such an important thing is that you're going to very often write functions where you want to take a variable that you initialize in your main function or in somewhere else and make a permanent change to it. If you want to make one of these kinds of permanent changes, this is where you need to use something like pass by reference. Otherwise, anytime you modify things in your maybe less or more funny function than mine, the changes aren't actually going to persist outside of the function when you're done with it. We saw when I didn't have the little ampersand here, when I modified the number by squaring it, that didn't affect the main function at all. And so if you need your function to actually make changes like this, that's where it's really important to use a pass by reference function to do so. So I think that's oh yeah, there's one more thing we're going to do, which is we're going to add const before the parameters in the functions and see if that does anything. So let's put that here, const. Interesting. It gives me an error, assignment of read-only reference num. Well, that's not so good. What happens if I don't have this ampersand? Also no good. So what exactly is going on here? Why is this happening? The const, the keyword const put before a variable indicates that this is a constant. It's something that's not going to change. So the reason that my code is messing up right now is because inside my functions, I want to change the number, and const says, no, you're not actually allowed to do that. You're going to get an error. Now, if I wanted to, I could declare a different kind of variable. Let's say I'm going to do a second number, right? Constant int hello. Sure, just for fun. And when I call my funny function, let's give this a value of num as well. I mean, why not? We'll make a little loop here. I is 0, I less than hello, I plus plus. I'm just going to say hello. Hopefully you're getting close to the point where writing these loops is something you don't have to think too much about. You just write everything in it down and it does what you want. And in this case, I just want to say hello this number of times. Now this will actually do what I want in terms of printing hello a bunch of times, and it won't give me any errors. And the reason it doesn't give me any errors, I put in 5 and it prints hello 5 times, is because I've indicated using the const keyword that hello is a variable that will never change. As long as I don't change it, C++ will be happy with it, and you can do what you want. You can make it, in this case, a variable, so to speak. It could have a bunch of different values depending on what the user writes in, but once it has been set up inside of this funny function, it will never be modified. And this might be something that you indicate, for instance, if you're going to give your code to somebody else. Maybe you and a partner were working on a project together, and you wanted to make sure that they never modified this variable because it's supposed to say the same thing the whole time. You can use a keyword like const to essentially put in your own little warning to say, hey, you've changed this variable, you're not supposed to, please don't. And so it's not something I think that is going to be necessary to get your code to work, but it's one of those kinds of things that in the real world you might see very often, and it's good to know what these kinds of special keywords indicate in C++. So just a little add-on to that exercise so you can see exactly what it means. But hopefully this video was useful for you, and make sure to do lots of practice because your tests are coming up. So see you there.